right, everybody, welcome back to Physics with Mr. McQueary. Today we're going to be talking about the metric system, and we can start off here with King Henry VIII, and he's talking about one of the fundamental aspects of the metric system. That's the powers of 10. All right, so we're going to get a little bit into King Henry, why he's important, and we're also going to talk about how the powers of 10 can make our life easier dealing with this neat system we've got. Our learning target for the day is to convert one unit to another within the metric systems. We're going to have problems where we go from centimeters to meters. We're going to have problems where we're going from kiloliters to centiliters and everything else in between. And we're going to try to get that skill down. And I think you're going to be pleasantly surprised how simple that can be. So the first question is, like Jerry Seinfeld, what's the deal with the metric system? Many of you might be too young to remember Jerry Seinfeld. And that was kind of his shtick. But what is the deal with the metric system? Why is it important? Why do we use it? Why is it a thing, right? Well, imagine we're trying to measure Jerry, okay? See how tall he is. Well, you can do that a few different ways, right? You could measure him in maybe how tall he is in iPhones, or maybe measure him in baby seals, or measure him in Crocs, right? And the problem with both of those, all those, is that they can all be different, right? I mean, that you might have a really big baby seal, you might have a really small baby seal. So he might be 5 small baby seals, maybe only 2 big baby seals tall. Or maybe if you're going back and forth between different versions of the iPhone, an iPhone 11 versus an iPhone 7 might get different results. Or like, I have really big feet, for example. My Crocs are going to be a lot larger than the normal person's, right? So it's going to be less Crocs for me to get that same measurement. So one of the big things when we're trying to measure things, we want to have, a standard measurement that we're using. Things that everyone can use. It's all the same thing we can all agree on that we're going to measure with. Otherwise, there could be horrible consequences, all right? And so we started doing this, a little bit of a history lesson here. We started standardizing our units, trying to make them all the same. And you may have heard these before come up in literature or maybe pop culture. Things like the cubit. We used to measure, the ancient Egyptians started this. They measured from your elbow to your fingertip and said, oh, that's about 18 inches. They didn't say 18 inches, but they said that's about a cubit. But then think about, an NBA player, think about his cubit versus maybe like a gymnast, right? They're going to have very different sized arms, very different sized cubits. So if they try to measure the same object, they're going to get different results. So along came a couple different things we tried. One of them was called the Gunter chain. And kind of like how we measure in English units or imperial units, we measure our land in terms of acres. Or in the metric system, we're talking about square kilometers and square meters. We measure with this thing. We basically try to measure it off. We loop it around a piece of land, and we say, oh, that's 1 Gunter. And that was an attempt to make things standardized. Also, we had the Scandinavian mile that came along, which, fun fact, it's neither Scandinavian or 1 mile. It's actually Roman, and it's 10 miles. So I'm not sure where that name came from. But we tried these over the years. And eventually what we had small pockets of standardization where one village would use all the same units, but then the next village would have a completely different set of things that they measured from. As a matter of fact, there's a guy that came along in France you've probably heard of called Charlemagne. And Charlemagne, among his many feats as a military strategist, some of the great things he did for language and learning and that kind of stuff, one of the other things he did was he also tried to standardize a few units. He said, okay, well, we're going to take all the things in France, all the units we have, and we're going to say these are the units we're measuring with. Well, that sounds great, but there's a lot of little towns in France, and he says that they're all going to be valid. And so there were over 800 measurements just for length. So if you went to like a tailor and you said, I want to measure, some fabric here so I can make clothes. Well, he'd ask you, well, do you want it in this or this or this or this or this? You have 800 units to choose from. I mean, try to imagine we have hard enough time with inches and feet or centimeters and meters, and those are only 4, right? And to get from those measurements to the other ones, there were over 25,000 different conversions where you were converting from one measurement to the other, like we do from centimeters to inches or something like that. try to think about, trying to memorize all his conversion factors. All right, so Charlemagne started, but he certainly didn't finish it, right? Well, along came 5 dudes, all right? And in 1790, they got together, and they're in Paris, France. You guys know what's going on in Paris, France in 1790, right? French Revolution's going on, right? And this guy over here on the left, this Marquis de, I'm sure I'm butchering this, Condorcet, got together with his 4 guys here, and he's like, guys, you know what this place really needs right now? You know, people are getting, like, the king has been beheaded. There's the guillotine. There's the reign of terror. This place really needs the metric system. I know, right? That was his priorities life. And these 5 guys set out. They said, we're gonna make a brand new revolutionary system of measurements. All right, and there's 3 rules we're going to follow when we're trying to make this. Okay, we're going to base everything on units of 10 because 10 is easy to deal with. All right, none of this 12 and 4 and 8 and 16 crap. We're going to do units of 10. And we're going to have one master unit of measurement. And they call it, and they eventually agreed it was going to be the meter. And we're going to base everything based on that. So what that means is that you can get to liters from meters. You can get to grams from meters. You can get to lumens from meters. You can get to moles from meters. Meters is the base of the metric system, believe it or not. And they said that meter is going to be based on the meridian. All right. So basically, they wanted that to have something in nature that you could base it. They wanted to make up an arbitrary length. They said, we want to have this based on something, which begs the question, where do we get the meter from? Like, why is it the length it is, right? You've got this meter stick here on the left. We got a whole bunch of them in my classroom. Why is it how long it is? Well, they set out and they said, we want to take, we want to draw basically an arc from the North Pole all the way down to the equator, okay? That arc right there. And we're going to divide it 10 million times, and we're going to call that a meter. So it's 1/10 millionth of the distance from the North Pole to the equator. That was the idea. And these guys spent 7 years trying to figure out how long it was from the equator over here to the North Pole. 7 years to do this, all right? And they ran, and it's a pretty good story if you want to research it. They basically used a whole bunch of trig stuff and trigonometry that you thought you would never use again after you took it in class, right? But they actually used that to try to help calculate. Now, based on the fact that they made a couple of erroneous assumptions, like they didn't realize that the Earth was, squished, not completely round, and the fact that they fudged some numbers too. One of the guys was just wrong on his calculations. We actually messed up. It's not, the 1 meter is not 1/10 millionth of that length. But we kept it anyway because we'd already decided that was going to be it. So the meter it's made up. It's kind of depressing. That's how it works. And from there, we were able to derive all those other units. Remember, they said that they had to be able to derive all the other units from one master unit. Well, we did. All right. So for mass, we have, we got kilograms over here. Time is in seconds. Temperature is in Kelvin. Brightness is candela. And the amount of substance, you guys remember that from chemistry, right? The mole. And we got our symbols over here. And there's a couple fascinating stories about why we chose those particular units. You think about like temperature, you probably think of Celsius and you probably think of Fahrenheit, but you probably don't think of Kelvin, right? That's named after a guy, Lord Kelvin. Kilogram always surprised me because you look over here on the left, on the right, and all these are like base units: meter, second, Kelvin. That you would think that would be gram, right? Well, that's what they originally said. They said, hey, we're going to have the gram be the base unit. But you've probably realized this. Grams aren't real helpful when you're trying to measure big things. Like if you're trying to measure the weight of a person, for example. If you tell someone's, weight in grams is going to be thousands of grams, and who wants to admit that they weigh thousands of something? So we change that to kilogram. That sounds better. And then you have seconds, which was interesting story there. With meters, when we were trying to measure how long is a meter, Thomas Jefferson had an idea, of all guys. Our Thomas Jefferson. And he told the guys that are working on the project, he said, hey, I got an idea for how long the meter should be. We're going to take a pendulum and we're going to say however long it is, for it to swing back and forth to take 1 second, we'll call that a meter. They said, great. All right, Thomas, here's our next question. How long is a second? So they couldn't do his method because they didn't have a standard measure for second, right? They had to go find the meter first, then find second, which is interesting. And we really don't use candela a whole lot. That's brightness. It's literally how bright is a candle. So that's where that word comes from. And if you're really into this stuff, there's some great books by Isaac Asimov about the history of units. If you want to look more into that. Let's get into our skills. Now we have our baseline unit here. What's the system that people work so hard for, back in the 1700s? Let's see if we can convert with that. But first, did you ever wonder about these guys? Have you ever heard any of their names before? Maybe. LaGrange sounds like, kind of sounds like the city is close to us, right? That's not the same guy, though. Laplace, if you guys ever get into Calc 4, the Laplace transform, that's him. That's all his stuff. You can look that up. It's really confusing, but it's interesting. And unfortunately for these 5 guys, they work so hard for this system. 2 of them are actually guillotined during the French Revolution. One of them is arrested, supposed to be guillotined, and then dies when he's in prison. And the other 2 guys make it out all right. So it's a kind of a cruel fate for them. And then in the 1800s, to make things worse, this guy named Napoleon comes around, and he decides he wants to get rid of the metric system. So they kind of get rid of it for a few years here while he's ruling, and then they bring it back after he's defeated. So interesting story with the metric system. Let's get to the conversion part. All right. So we take advantage of the fact that everything can be divided or multiplied by 10, meaning all we got to do is move a decimal. That's good news for us. All right, so we take this, we got this metric prefix scale over here, and these are all the prefixes, the things that go in front of the base units. Kilogram, kiloliter, kilometer, right? That's the thing you stick on the front of it, right? Centimeter, centigram, centiliter, all right? You've heard that before, all right? So that right here, that denotes a particular power, all right? And we really stick to this part right here from about 10 to the 6 to 10 to the -6 for the most of the year, all right? As a matter of fact, for today, we're really just going to stick from 10 to the 3rd to 10 to the -3rd. So we're just going to worry about these prefixes here in the middle. All right. You remember King Henry? Well, say, sure, I remember King Henry, right? King Henry's the guy with all the wives, right? And they split the church over him, and that's great, right? But did you know there's actually 9 different King Henrys? Here's 5 of them. So you could be referring to, not 9 different ones. And there's some pretty interesting stories on just about all of them, actually. This guy right here is like the modern day football pep talk guy. Look him up, King Henry V. So pretty cool stories on them. We have this helpful mnemonic that helps us to remember all those prefixes, all those kilos, all those, decis, all those centis, and it can be hard to memorize them, but we're going to give you a little mind device here. You kind of sing along in your head to try to help you remember the order that those go in. So ours goes, King Henry died by drinking chocolate milk. All right. And the K stands for kilo, H stands for hecto, D stands for deca. Now the B here is for base. That's like your base units, like your gram and your meter and your liter and that kind of stuff. D for deci, C for centi, M for milli. All right, so we can use that nice little mnemonic device to remember the order those go in. All right, so here's what we're going to do. When we're converting these back and forth, simple method, very little math involved. I think you're going to like it, all right? We're going to draw this line on paper and we'll put 7 little tick marks. 1, 2, 3, 4, 5, 6, 7. Okay. Now we're going to go back and we're going to put little abbreviations here above it. So King Henry died by drinking chocolate milk. This DA, all right, that's because deca, the abbreviation for that is actually DA, not just D. So you got to be careful on that. King Henry died by drinking chocolate milk. Kilo, hecto, deca, base, deci, centi, milli. All right. And if you want to, you can go ahead and write the base units down here. All right. Remember, we want to, label those. If we have a centimeter, we just stick a C on front of this. Or a centiliter, we stick a C on front of this. Or maybe a deca, decagram, dag, or decameter, dam, right? You just stick it in front of it. All right, now the next thing we're going to do is we're going to start with, and this is really wordy, we're going to start with the unit that you've been given, all right? Because most problems say, here's this many units converted to this many units. So we're going to put our original unit, we're going to put a pencil on it, all right? And then we're going to move however many jumps, however many tick marks we need to get to our new unit. Watch this. All right, 56 centimeters. We're going to put our pencil right here on the C because that's what we're given. We want to get to millimeters. So millimeters is over here, right? Because there's the M, right? M for milli. So we jumped once to the right. Okay. So because we jumped once to the right from centi to milli, we're going to move our decimal one to the right. Okay. See, right? We went to the once to the right. So we're going to have our decimal started here. We're going to go once to the right, just like our jump. So now we have 560 millimeters. That's it. That's the whole thing right there. There's very little math involved, right? We're just moving decimals back and forth. Let's try another example. 7.25 liters. So liters is a base unit, right? That's one of our base units here. We want to get to kilometers, which is way over here, or kiloliters, I should say. So we're going to make 1, 2, 3 jumps to the left. So our decimal is going to go 1, 2, 3 jumps to the left. All right, yep, just to double check, we did go 3, good for us. 1, 2, 3, boom, there goes our decimal. All right, so we have less than 1 kiloliter, right? And that's right, because kiloliters are a lot bigger, right, than a liter. So 7.25 liters should be a lot less than 1 kiloliter, right? All right, it's kind of a way to check yourself. Let's do this one over here. 45,000 grams. I got grams over here in the middle. We want to get to milligrams. So we'll go 1, 2, 3 jumps to the right. So we're going to go here. We draw our little decimal. We go 1, 2, 3 to the right. So we're going to add those 3 zeros. 45 million milligrams. All right. And milligrams, you know, are a lot smaller than grams. So it makes sense that when we go from grams to milligrams, it gets a lot bigger, right? Another good way to check yourself. All right, now we're going to try this problem again here. We got centimeters, so we're way over here. And we're making the jump all the way to kilometers. We got to jump 1, 2, 3, 4, 5 to the left. Here's our decimal. 1, 2, 3, 4, 5 to the left. All right, so we've moved that decimal. We put in our zeros here as placeholders. And look at that. Not too bad, right? You basically went from one end of the spectrum to the other, and we can do this no problem, right? Okay, let's do this real quick here. Millimeters to centimeters, pretty easy one. One jump to the left, right? With this guy, one jump to the left. 3.5, good for us. Liters to kiloliters. 1, 2, 3 jumps to the left. 1, 2, 3 jumps to the left. Look at that. Not too bad, right? Kilograms. 1, 2, 3 jumps to the left. 1, 2, 3 jumps to the left. Okay. Liters to milliliters. 1, 2, 3 jumps to the right. 1, 2, 3 jumps to the right. Last but not least, millimeters to kilometers. 1, 2, 3, 4, 5, 6. That's a doozy. 1, 2, 3, 4, 5, 6. We're going to have 4 zeros in the middle there. Yes, we do. And just to kind of wrap it up here, the metric system, you think of it as this all-encompassing set of measurements, the system of measurements, but it kind of is. I mean, there's only 3 countries in the world who don't, right? Just America, Liberia, and Myanmar. That's it. And kind of makes you wonder why we haven't gone on board yet, right? So actually, the reason why we don't is because think back to World War II, right? In World War II, we were fighting on the side of the Allies with Britain and the Soviet Union. And who was making all the war material? America was, right? So after the war, we actually made up over 2/3 of the world's economy because we had just kicked our economy into overdrive. So basically, we told countries, if you want to trade with us, you're going to have to accept our measurements. And because we've held such a dominant place in the world economy since then, we've been able to keep our economy. We made everyone kind of conform to what we were doing. And other countries have kind of tweaked the metric system a little bit to make it compatible with us. For example, if you order a pair of shoes in Australia, they don't use a metric system for shoes. They use something that's pretty close to what we use for shoes. And that's because during World War II, we had so many American troops stationed in Australia. We made up a huge portion of their economy, and they were making more money supplying the American troops with shoes, for example, than the Australian population with shoes, because we were going through so many of them. And we even have a few, bits of the metric system in our, in our country too, right? Don't forget about that. I mean, we still, for time, we use seconds, right? We also use minutes and hours, but we also use seconds and nanoseconds, right? And that's something that's straight from the metric system, right? So it's interesting to see, and I know it can be kind of boring talking about the metric system, but there's some neat history involved, and why we chose certain things and went certain directions. For our intents and purposes, we know that they're there. We know they're good stories, but we're more concerned with how we can convert back and forth, right? And I think with that decimal trick, they'll make things a lot easier for us. All right. So today's lesson was about the metric system, what's it all about, and how do we convert it. Until next time, see ya.